In Johannesburg in June, the daily low temperature is usually around 3 degrees Celsius, and the daily high temperature is around 18 degrees Celsius. The temperature is typically halfway between the daily high and the daily low at both 10 a.m. and 10 p.m., and the highest temperatures are in the afternoon. Write a trigonometric function that models the temperature capital T in Johannesburg, lowercase t, hours after midnight. So let's see if we can start to think about what a graph might look like of all of this. So let's say this is our temperature axis in Celsius degrees. So that is temperature. And I'm actually going to do two different functions. So that's my temperature axis. And then this right over here is my time in hours. So that's lowercase t, time in hours. And let's think about the range of temperatures. So the daily low temperature is around 3 degrees Celsius. So let's actually, and the high is 18. So let's make this right over here 18. This right over here is 3. And we can also think about the midpoint between 18 and 3 that we hit at both 10 a.m. and 10 p.m. 18 plus 3 is 21, divided by 2 is 10.5. So the midpoint, or we could say the midline of our trigonometric function is going to be 10.5 degrees Celsius. So let me draw the midline. So we're going to essentially oscillate around this right over here. We're going to oscillate around this. The daily high is around 18 degrees Celsius. The daily high is around 18 degrees Celsius, and the daily low is around 3 degrees. The 3 degrees Celsius, just like that. So we're going to oscillate around this midline. We're going to hit the lows and the highs. Now to simplify things, because we hit this 10.5 degrees at 10 a.m. and 10 p.m., to simplify this, I'm not going to tackle their question that they want immediately, the hour in terms of t hours after midnight. I'm going to define a new function, f of t, f of lowercase t, which is equal to the temperature in Johannesburg, where we're assuming everything is in Johannesburg, temperature t hours after, I'm going to say t hours after 10 a.m. And the reason why I'm picking 10 a.m. is because we know that the temperature is right at the midline at 10 a.m. T hours after 10 a.m. Because if I want to graph f of t at t equals 0, that means we're at 10 a.m. That means that we're halfway between, they tell us, we're halfway between the daily low and the daily high. Now, what is the period of this trigonometric function going to be? Well, after 24 hours, we're going to be back to 10 a.m. So our period is going to be 24 hours. So let me put 24 hours there, and then this is halfway is 12 hours. So what happens after 12 hours? After 12 hours, we're back at 10 p.m., where we're back at the midway between our lows and our highs. And then after 24 hours, we're back at 10 a.m. again. So those are going to be points on f of t. And now let's think about what will happen as we go beyond, as we start at 10 a.m. and go forward. So as we start at 10 a.m. and go forward, they tell us that the highest temperatures are in the afternoon. The afternoon is going to be around here. So we should be going up in temperature. And the highest point is actually going to be halfway between these two. So it's going to be 6 hours after 10 a.m., which is 4 p.m. So that's going to be the high at 4 p.m. So let me draw a curve, draw our curve like this. So it'll look like this. And then our low, so now we're at 10 p.m. And then you go 6 hours after 10 p.m. You're now at 4 a.m., which is going to be the low. This is 18 hours after 10 a.m. After 10 a.m., you're going to be at your low temperature, roughly right over there. And your curve will look something like this. So what would be, before we even try to model t of t, what would be an expression? And obviously we keep going like that, and we could even go, hours before 10 a.m. This is obviously just keeps on cycling on and on and on forever. Now, what would be an expression for f of t? And I encourage you once again to pause the video and try to think about that. Well, one thing that you can say, well, you say this could be a sine or a cosine function. Actually, you could model it with either of them, but it's always easiest to do the simplest one. Which function is essentially at its midline when the argument to the function is 0? Well, the sine of 0 is 0, and if we didn't shift this function up or down, the midline of just a sine function, without it being shifted, is 0. So sine of 0 is 0, and then sine begins to increase and oscillate like this. So it feels like sine is a good candidate to model it with. Once again, you could model it with either, but I have a feeling this is going to be a little bit simpler. Now let's think about the amplitude. Well, how much do we vary? What's our maximum variance from our midline? So here we are 7.5 above our midline. Here we are 7.5 below our midline. So our amplitude is 7.5. And actually, let me just do that in a different color just so you see where things are coming from. So this is 7.5. This is 7.5. So our amplitude looks like it's 7.5. And now, what is our period? Well, we've already talked about it. Our period is 24 hours. This distance right over here is 24 hours, which makes complete sense. After 24 hours, you're at the same point in the day. So we would divide 2 pi by the period, divided by 24 times t. And if you forget, hey, divide 2 pi by the period here, you could just remind yourself that what t value will make us go from, so when t is equal to 0, the whole argument to the sine function is going to be 0. That's when we're over here. And then when t is equal to 24, the whole argument is going to be 2 pi. So we would have made one rotation around the unit circle if we think about the input into the sine function. Now we're almost done. If I were to just graph this, this would have a midline around 0, but we see that we've shifted everything up by 10.5. So we have to shift everything up by 10.5. Now, we've just successfully modeled it, and we could simplify a little bit. We could write this as pi over 12 instead of 2 pi over 24. But this right over here models the temperature in Johannesburg T hours after 10 a.m. After 10 a.m. That's not what they wanted. They want us to model the temperature T hours after midnight. So what would T of T be? We're going to have to shift this a little bit. So let's just think about it a little. Let me just write it out. So T of T, this is now, we're modeling T hours after midnight. So we're going to have the same amplitude. We're just going to have the same variance from the midline. So it's going to be 7.5 times sine of, actually let me do the same color so you see what I'm changing and not changing, times the sine of, instead of 2 pi over 24, I'll just write pi over 12. Instead of writing t, I'm going to shift t either to the right or the left. And actually, you could shift in either direction because this is a periodic function. We're going to have to think about how much we're shifting it. So t is going to be plus or minus something right over here. I'm going to shift it plus 10.5. Plus 10.5. Now, this is always a little bit, at least in my brain, I have to think about this in a lot of different ways so that I make sure that I'm shifting it in the right direction. So here at 10 a.m., we were at this point. When t is equal to 0, this is 0 hours after 10 a.m. But in this function, when is 10 a.m.? Well, in this function, 10 a.m., let me write it this way. 10 a.m. is 10 hours after midnight. So t, capital T of 10, this is 10 hours after midnight, should be equal to f of 0. Because here, the argument is hours after 10 a.m. So this is 10 a.m. This right over here represents temperature at 10 a.m. And this over here, because this capital T function, this is hours after midnight. This is also temperature at 10 a.m. So we want T of 10 to be the same thing as f of 0. Or another way of thinking about it, when f of 0, this whole argument is 0. So we want this whole argument to be 0 when t is equal to 10. So how would we do that? Well, if this is t minus 10, notice, t of 10, you put a 10 here, this whole thing becomes 0. This whole thing becomes 0, and you're left with 10.5. And over here, f of 0, well, the same thing. This whole thing becomes 0, and all you're left with over here is 10.5. So t of 10 should be f of 0. So if we wanted to graph it, we've already answered their question. If we put a 10 here, the argument to the sine becomes 0. These two things are going to be equivalent. But let's actually graph this. So t of 10, so if we're graphing capital T, t of 10, so this is 6, 12, let's see, so this is maybe, so 10 is going to be someplace around here. So t of 10 is going to be the same thing as f of 0. So it's going to be like that. And then it's just going to, and then we've essentially just shifted everything to the right, by 10. And that makes sense because 0 after, whatever hours you are after 10 a.m., it's going to be 10 more hours to get to that same point after midnight. So your curve is going to look, so this is going to be shifted by 10, this is going to be shifted by 10, and your curve is going to look something like, let me see, this is going to be shifted by 10, so you're going to get, it's going to be at 16 hours, so let's see, it's going to look something like that. And of course, it'll keep oscillating like that. So essentially, we just had to shift it to the right by 10. The argument, we had to replace t with t minus 10 to do it, and this was the logic why.